Welcome back to the next video, everybody. Today, we're going to be looking at functors and their representability and their pro-representability. So the setup is that lambda will be a coefficient ring with residue field K of characteristic P. C hat lambda of A will be the category whose objects are coefficient lambda algebras endowed with a coefficient lambda algebra homomorphism to A, which remember we call an A augmentation. C lambda of A will denote the full subcategory whose objects are Artinian, so they satisfy the descending chain condition on ideals, coefficient lambda algebras endowed with an A augmentation. If A is the residue field K itself, we'll just drop it from the notation. So we'll just write C hat lambda and C lambda instead of C hat lambda K and C lambda K. The reason for this setup is that for any coefficient ring A, we can write it as an inverse limit of Artinian coefficient ring, so things in that full subcategory, by just writing A as the inverse limit over n of A mod m to the n sub A, where m sub A is the unique maximal ideal of A. Okay, so what does it mean for a functor to be representable? Let's let C be a category and let's let D from C to sets be a functor. We'll say D is representable by representing object C if there's an object C in the category C, such that D is naturally isomorphic to the functor of point H sub C of C. That is, if for every object A and C, there's a functorial isomorphism, D of A to H sub C of A, and H sub C of A is by definition, the C maps from A to C. Okay, so what you should think about is like, D of A is just the A points of C, essentially, okay? Because maps from A to C can be thought of as points of C that are like A valued somehow. This is a common viewpoint in algebraic geometry. Okay. If we have a given functor D on the larger category, so that full category C hat lambda from above, that is representable, the representing coefficient lambda algebra, let's say R, is then actually completely determined by the restriction of the functor to that smaller category where the objects are Artinian. And the reason for that is simple. The functor hom R dot just commutes with inverse limits. Like this is just a well-known like algebra fact, okay? Well, that means if D also commutes with inverse limits, so if D, the functor itself, also commutes with inverse limits, it's just simply more convenient to work on that smaller subcategory, so on C lambda. And so we'll give a name to this setup. We'll say that D is continuous if it commutes with inverse limits. That is, if D of A is just the same thing as the inverse limit over n of D of A mod m to the n of A for all coefficient lambda algebras A. So what we're saying then is that a continuous functor on C hat sub lambda is just determined by its restriction to C sub lambda, the Artinian guys. All right. So what does it mean for a functor to be pro-representable? A functor on C lambda, which is represented by an object in the larger category, C hat lambda. So it's not represented by an object in itself, but maybe in the larger category. This is going to be called a pro-representable functor. This is because they're represented by inverse limits, so hence the pro prefix, of objects on their category of definition, C lambda, okay? Basically by the above discussion. However, we will often drop the prefix pro unless we really need to specify. Okay, so next video will be all about fiber products and categories and how the notion of the fiber product relates to representability. So I'll see you then. Thanks for watching.